Hey everyone, welcome back. Hope you had a great week. I'm glad you liked my video on pre-calc. Interestingly, it got more views than the calculus video I created earlier. Thank you for comments and suggestions about integration by partial fractions. To be honest, I haven't learned that yet myself, but I will do that in the future, hopefully. Today, I'm going to cover matrices. If you've ever wondered what a matrix is, some basic operations, and why we need it, stick around. First up, what exactly is a matrix? A matrix is just a way to organize numbers into rows and columns, kind of like a table or a grid. Matrix size is represented using two numbers. First one is row count and second one is column count. For example, a matrix of 2 by 3, which you write like this, 2 by 3, will have 2 rows and 3 columns. It will have 6 total elements arranged in 2 rows and 3 columns. So for example, like this, 1, 2, 3, 4, 5, 6. 2 rows and 3 columns. Can a matrix be of 1 by 1? Yes. For example, this is a matrix of 1 by 1. 1 by 1. But why do we even care about matrices? Well, matrices can help us store information, solve system of equations, and even power 3D graphics in video games. Representing graphical images is done using matrices. Scaling, rotating of an image is done using matrix operations. Even modern AI uses matrices to store knowledge, so matrices are actually quite useful. Before we get to the basic operations, let's clarify a few concepts first. First one is identity matrix, which means diagonal elements are 1 and everything else is 0. So for example, this is an identity matrix because as you can see, this is the diagonal of 1s and everything else here is 0. Another thing to know is transpose of a matrix, which means to swap rows with columns. Now let's learn some basic operations. First up, adding and subtracting. Then multiplying by scalar, and then a bit of a complex concept of multiplying two matrices. Let's start with adding or subtracting two matrices. This is pretty easy and straightforward. However, the requirement is that both matrices have to be of the same size. It means both should have the same number of rows and same number of columns. Now, with that, let's see this as an example. Let's say matrix A is equal to 1, 2, 3, 4, 5, 6. And let's say matrix B is equal to 2, 4, 6, 8, 0, and 2. So now, if we have to add A and then B, then A plus B will be the size of 2 by 3 as well. As you can see, this has 2 rows and 3 columns, so it's 2 by 3. 2 rows, 3 columns, so it's also 2 by 3. And our answer is also going to be 2 by 3. So adding and subtracting matrices is quite easy. To do it, all we have to do is add the digits in the same position. So for example, to add 1 plus 2, it's going to be 3. So this is our first one. 2 and 4. So this is going to be our second one, which is 6. And then 6 and 3, 9. And then 8 plus 4, 12. And then 5 plus 0, 5. And 6 plus 2, which is 8. So this is our resulting matrix, which we can call C, let's say. And we got that by adding these two. So C is equal to A plus B. Now let's look at scalar multiplication. It's basically scaling, as in growing or shrinking, each element of a matrix by some scalar factor. Scale factor can be positive, negative, or even a fraction. Let's take this example. Let's say matrix A, 1, 2, 3, 4, 5, 6. Then, how will we find out what negative 3A is equal to? Well, scalar multiplication is quite easy. All we do is multiply each element by negative 3. So, let's do this. Negative 3 times 1, negative 3. Negative 3 times negative 2, which is 6. Negative 3 times negative 3, negative 3 times 3, is 9. Negative 3 times negative 4 is 12. And negative 3 times 5 is going to be negative 15. Negative 3 times 6 is going to be negative 18. So this is our resulting matrix. Now the operation of multiplying two matrices. This one has some requirements and some rules. Two matrices can only be multiplied if the column size of the first one is equal to the row size of the second one. So the column size of the first one, which is this, the column size of the first one, is equal to the row size of the second one. And this is the row size, this is the column. For example, let's say the first matrix is 2 by 3. And the second matrix is 3 by 1. So let's say A is 2 by 3 and B is 3 by 1. Then A can be multiplied with B. But note that B cannot be multiplied with A because column size of B is 1 and that is not equal to the row size of A, which is 2. However, column size of A, which is 3, is equal to row size of B, which is also 3. So this means A times B is possible, but B times A is not possible. And one important thing is, what would the size of the resulting matrix be? Well, it'll have a size of rows of the first matrix and columns of the second matrix. So our resulting matrix will be 2 by 1. Now, let's see how actual multiplication is done. The big picture idea is basically we start with the rows of the first matrix and go over each column of the second matrix. Let me show you that with an example. Let's say our matrix A is equal to 1, 2, 3, 4, 5, and 6. And this is a 2 by 3 matrix. And let's say our B is this. So it's going to be 2, 4, 5, 8, and 3, and 1. And this is 3 by 2. Now, just to check, let's see if this is even possible to multiply A by B. Let's see. So the column of the first one, which is 3, is equal to the rows of the second one, which is also 3 in this case. So yes, we can multiply. And our resulting matrix size, we know it'll be 2 by 2. So here's how we do this. First, we take this 1 over here. So first we start over here, and then we multiply it by this. So now 1 times 2, sorry, we know is 2. So our first one, or not our first one, but so it's going to be 2 plus, and now we know that this is negative 2 times negative 5. And we know that is negative 10. And then we have 3 times 3, which is equal to 9. So now we did the first row with the first column. Now we also have to do first row with the second column. So 1 times 4 is 4, plus negative 2 times 8, which is negative 16. And then we have 3 times 1, which is just 3. So now we're done with our first row. Now let's move on to the second row. So our second row over here for the first one is negative 4. So now we do negative 4 times 2, which is going to be negative 8. And then we have 5 times 5, which is 25. Then we have 6 times 3, which is 18. And then now we did second row, first column. Now we have to do second row, second column. So now we do negative 4 times 4, which is negative 16. Then we do 5 times 8, which is 40. And then we have 6 times 1, which is just equal to 6. So doing the calculations, this is what we got. Now we just have to put it in the resulting matrix. So this one will go over here, and this negative 9 will go over here, and this 35 will go over here, this 30 will go over here. The product of AB is equal to this. And that's it. Don't worry if it feels confusing at first. It's not very complex, but it's just a little bit tricky to follow. Before we wrap up, did you know that Google Search, 3D movies, and even weather forecasts use matrices? Matrices are literally everywhere. Alright, today we learned what matrices are, why they're important, and how to do basic operations. If you found this video helpful, don't forget to like, share, and subscribe. I'll see you in the next one. Goodbye.